All right, so solutions here for question number 1. Okay, we first want to break this up into part 1 and into part 2. Okay, so in part 1, we know that they are moving at a velocity of 20 meters per second due north, and they go 185 meters due north. And then in part 2, we know that they are going to chase the deer another 83 meters, but it's south because they fall down and turn around. And they do that for 9.48 seconds. Okay, we want to find the average velocity of the bear. So we have our totals column here. Okay, so here's what we need to do. Average velocity equals total displacement divided by total time. Okay, right now I can do the total displacement because I have 185 meters north, I have 83 meters south, okay, which is going to mean I take my 185 and I add a negative 83. Okay, I am going to have 102 meters north for my displacement. Okay, I don't have my total time because I don't have the time for part 1, but that's easy to get. It's d over v, 185 over 20. Okay, we'll get that for me. So 185 divided by 20, and it gives me 9.25 seconds. Okay, so I've got 9.25 seconds and 9.48 seconds. So if I want my total time, it's 9.25 plus 9.48. And we add those two together, plus 9.48. And it gives me a total of 18.73 seconds. And then it's simply 102 total displacement divided by my total time for an average velocity of two significant digits, 5.4 meters per second north. The north is essential. You must have that on your answer. All right, for question number 2, we got a velocity versus time graph here, okay, and we are looking for average velocity. The thing we need to remember about average velocity is that it is total displacement divided by total time. We have the total time already, okay? The total time for this trip is 10 seconds according to the graph. Okay? If I want to get the total displacement from this graph, that's where all the shapes come in. So I'm going to have that rectangle, this triangle, and this triangle, this rectangle, and this triangle, okay, all of which I need to get the area of. So this rectangle here has a height of 30 and a base of 2, so that one's going to be 60 meters, and it's positive. Okay. This triangle here has a base of 2 and a height of 30. It's basically half of this rectangle, okay. That makes it positive 30 meters. Okay, I have this small triangle here, which has a base of 1 second and a height of negative 17.5. Okay, so negative 17.5 divided by 2 is going to be 8.75. I don't know, I shouldn't do mental math. Okay, 17.5 divided by 2. I was right, 8.75. I can do mental math. Okay, 8.75 meters. This triangle here is identical to that one, so I'm just going to fill it in right now, negative 8.75 meters. Okay. And then I've got this rectangle here that is 1, 2, 3, 4 seconds on the base by negative 17.5 high. So 17.5 times 4. Okay, it gives me 70 meters there. Okay, so now if I want to get the total displacement, I've got to add all those up, keeping the vectors in mind here. Okay, so I'm going to have positive 90, okay, plus negative 87.5. Okay, because that's 70 plus 17 and a half. Okay, and I've got 90, 60 plus 30 here. Okay, so when I do that, I'm going to end up with a total displacement, okay, of positive 2.5 meters. Okay, that's what we end up with. Okay, and so once I have that, now I can do my total displacement over total time. I'm going to get that my average velocity is positive 0.25 meters per second. Okay, pretty typical velocity versus time graph question.